Jai Hind everyone. Myself Rupak Kumar. I am from IT department. Today we are going to know about the database management system. The topic is basically serializability. So first schedules, or if we talk about the schedules in a database management system, then we can say schedule is basically are of two type. Means schedule may be a serial schedule or it may be a non-serial. Two things is over there. It may be a serial schedule or either non-serial schedule. Then if it is serial, then nothing to say next. But if it is non-serial, so we have to make it serial. So for this we have two types. Means non-serial schedule divided into serializability and non-serializability. So today we see what is serializability. Serializability of the scheduling algorithm. So first come to know about serializability. So if we say what is serializability, so only non-serial schedule need to be checked for serializability. If the schedules is non-serial, then only we are going to check for the serializability. If it is serial, then no need to check. So that is what written here. Only non-serial schedule need to check for the serializability. Clear? Next we can say the non-serial schedule is called serializable schedule, and if it can be converted into its equivalent serial schedule, means it is only said that it is serializable only if it can be converted to its equivalent serial schedules or result of serial or non-serial schedule is same. So we can say the seriality identify the correct non-serial schedules and that will be maintain the consistency of database. So we can say what is the how we say that it is consistent or not. So seriality identify the correct and non-serial schedule and that will be the maintain the consistency of database. So to maintain the consistency we can have a seriality identify the serial things over there. Now how we converted this by using the conflict and view. We can see in this chart that when the schedule is serializable, then how we convert into a serial schedule with the help of this conflict serializable and view serializable. So serial schedules, non-serial schedules is of two types, serializables and non-serializables, and if it is serializable then we can say it just converted to a conflict serializables and view serializable. So we see next that how it is converted. So if we take an example over there, so we can say that we have a serial schedule over there transaction, that is what read over a transaction A. We are if talking about same transactions, we have to go for the exact the same transaction, that is what read of A and write of A and read of B and write of B and then commit. So transaction 1 just complete whole of its operations at a time and then commit the operations. Then transaction 2 start reading the data item A and then writing the data item B and then commit. Means this is what the work is done in serial. So you can say the schedule S is basically serial schedule. Okay. Now how we just convert the non-serial schedule. If we take any non-serial examples over there, it is non-serial. Why it is non-serial? Because we can say that write of A, then read of B, read of A and write of B. Then we have a transaction 1. Then in transaction 2 we have a read of A, then read of B. We read the item of B and write of B and then commit. Means it is not in serial. In between there is another transaction start reading the data or writing the data, whatever it is. So then we can say that it is not a it is not a serial schedule, it is a non-serial schedule. So we can say if the schedule is non-serial, how we just convert it to a serial schedule. So to convert this into serial schedule, we just move this transactions of read of A over here after commitment after commit of first schedule. So then we can say this non-serial schedule as dash is converted into serial schedule when we just remove this transaction. Clear? Next So serializability can be done with the help of two types. One is your conflict serializability, another is your view serializability. We can say what is the conflict serializable. In this chart we can see non-serial, in serializable and non-serializable. Right now we are just talking about the serializable. It is conflict serializable. So what is conflict serializability? So a schedule is called a conflict serializable if it swapping of non-conflicting operations, means when the non-conflicting operations swap over up and downs, and it can be transferred it into a serial schedule. Means we can just transfer the conflict serializable schedule to a serial schedule. So what should be the conflicting pair? So here is three conflicting pair over there. First conflicting pair is basically read of data item A and same write of data item A. And read and write is the first conflicting pair. Second conflicting pair is basically write and write on data item A and write on data item A. Third conflicting pair we can say that is what the write and read. So this is what the conflicting pair. We have to find these conflicting pair in this schedule. So when we find this conflicting pair, we can just remove this conflicting pair and we just get the schedule as a serial schedule. So next, in this conflicting operations, so the two operations become conflict if all conditions satisfy. Means how we can say that the operations become conflict. Only operations become conflict when we say when these conditions satisfy. First condition is that both belong to a separate transactions. Both read and write belong to a separate transaction. Next, here they have the same data item. Means they just work on the same data item. Is here we have two data items, one is A and one is B. So there is a condition that both belongs to the separate transactions and have the same data item. Means transactions is separate and data item must be same. Means if we talk about this condition, that this is what the data item must be same and transaction must be different. This is what the conditions. It belongs to separate transactions and they have the same data item. And next is your they contain at least one write operations. So in that there must be one write operations over there. Then only we can say this is what the conflict serializable. Clear? So three operations over there: read write, write write, and write read. We can see how we just remember this read write, write write, and write read. We can see they are writing in every all the three pairs. Writing over here, writing over here, writing means writing condition तो होगा ही होगा है ना. It is over there. So we can say the writing operation is over there. And clear. So read write, write read, and write write. This is what the three conflicting pair. We must have to remember this pair properly so that we can do the problem ahead. So we see next. Now checking whether a schedule is conflict or not. How we can check the schedule is conflict or not? First step, while we going to check the condition, we must write here the conflicting pair. Here must be write. Here we must write the all the conflicting pair, and we already know the conflicting pair is read write, write write, and write read over a same data item. Talking about the same data item. Remember this thing also. So first step for all conflicting pair, find all the conflicting pair in the given schedule. So if we have any given schedule, we have to find the all conflicting pair in this given schedule. This is what the first step. So let's try the first step. Now first is your read of A. So if we talk about the read of A, then read is conflict with the write. So read of A is here, and anything write of A in another transaction. Write of A, no. So there is no any conflict pair. We have three conditions over there, no? Belong with a separate transactions. That is what means read of A is here, then write must be from 2 and 3 only. Clear? Next is your, they have the same data item, so we are just talking about the same data item, A only, so there is no any write of A. Clear? So this is not any conflicting pair, we just check for this. Next is your second, read of B, then we must have a write of B over there. No any write of B, means this is also not a conflicting pair. Next, read of A, then there must be write of A. Yes, write of A here. Here it is write of A. So there is a conflicting pair. This is on T3 there is a read of A, and in T1 there is a write of A. So this is the first conflicting pair we find in this transaction. Clear? Next, we just see for this read of B, then there must be write of B. Yes, it is here in T3. So read of B and write of B. This is what the another conflicting pair. Now next we find, we just do it, is clear. Now read of C, read of C over there, then write of C. Yes, write of C means T2 to T1 is conflict, T2 to T1 is conflict. This is the third conflicting pair. Next we have a write of B, then read of B, no read of B. Then we have a write of C, then there is much read of C. Yes, yes, read of C is there. So this is a conflicting pair, and T2 is the conflicting pair. Okay, there is a WC also in this, so we can write this over here. So we just find the first step, we complete, find all the conflicting pair, 1, 2, 3 and 4 conflicting pair is there. Now second step, to draw the precedence graph. How we draw the precedence graph? We can see, we draw the precedence graph. First we draw the transactions. There is 3 transactions, T1, T2 and T3. So we just write all these transactions. Then we start T3 to T1, T3 to T1. We just draw the draw a line from conflict from T3 to T1. Okay, T3 to T1. Next is your T2 to T3, T2 to T3. Next is your T2 to T1, T2 to T1. Next is your T2 to T1, T2 to T1 already draw. So this is what the precedence graph, with how we draw this precedence graph, with the help of these conflict pair in the given schedule. So this is what the process. First we see the transaction, we just find the conflicting pair by keeping in mind that both belongs to separate transactions, they have the same data items, they contain at least one write operations. So we see that this is what the conflict pair, then we just draw this precedence graph with the help of this conflict pair. Okay, so there, now what we see, no loops or cycle present in the graph. There is no any loop and cycle. What does this mean? Loop cycle means, if we draw like this, this is what the, no, this is not in this direction. If we draw in this direction, we can see this is the loop. It may be loop over there, kahin ho sakta hai. Then we can say another type of loop is that if this is in this side, then we can say this is also the loop. So there must not be any loop. So no loop or cycle present in this graph. में कोई loop and cycle नहीं होना चाहिए. There is no any loop and cycle. Second, schedule is conflict serializable schedule. Therefore, then we can say this given schedule is conflict serializable schedule. Clear? So 2 or 3 things we have to keep in mind. First, what is the conflicting pair? That is what given here. That is read write, write write and write read. Next is your we just have to keep in mind that both belongs to separate transactions and they have the same data item and they contain at least one write operation. This is all about your how to check whether the schedule is conflict serializable or not. Next, now how to find the conflict equivalent serializability with example. So what is the, suppose we have given some schedule. So there is a 2 schedule is given, schedule S and schedule S dash. Now find out if S equals to S dash, then what is the conflict equivalent of this? If S and S dash is equal, so first we just transfer this S dash to equivalence of this schedule. How we transfer this? Step 1, check the adjacent non-conflict pair as per rules. So we have to just find the conflict pair over there. So we see, is there any conflict pair in this read of A? Then there must be any write of A over here. Yes, there is write of A. Clear? Read of A and read of A. This is also read of A, read of A. Okay, so write the read of A. This is not conflict. Next, read of A and write of A. Read of A and write. This is conflict with these two. So we write these two. This is not a conflicting pair, but this is the conflicting pair. So write this conflicting pair over here. Next is write of A and read of A. This is also a conflicting pair. Next, we have a read of A and then we have a this is not a conflicting pair, है ना? Then we have a write of A and write of A conflicting pair. Then we have a write of B, a read of B and read of A, read of B and read of A. This is also not a conflicting pair, है ना? So in this we can see that this is not the conflicting pair, but this 3 is the conflicting pair. Now second step is say, if there is any conflicting pair is present, then swap the conflicting pair. So in this we have a conflicting pair of write of A and read of B, write of A and write of A and read of B and write of A, read of B and write of A. So we just swap this read of B and write of A. How we swap? We just move this to upward direction and this is what to the downward direction. Clear? So next we have a, after swapping of this to upside, we just come here. Just erase this first. So this is what the we just swap this to this. Then this is what the first swapping. This is schedule as dash. Then again we can see that there is also one more swapping over there. We just move this again upward so that there is some seriality. To make it serial, we just swap this to up to this. One stage swapping this, then down, and one stage swap this, and then put it in down. Then we can see now it is a serial. Now we can say this S dash, S and S dash is now serial, equal schedule. See, so conflict equivalent serializability. In this example, we can check this how we convert this conflict to a equivalent schedule. Clear? By swapping of this transaction. Clear? Next is your view serializability. So why view serializable and what is this? So we can say the view serializable. If we talk about the view serializable, there may be some schedule that are not conflict serializable. Means, but given consistent result. There is no any conflict, but they give the result as a consistent manner. Next we can say concept of conflict serializable become limited when the precedence graph of a schedule contains a loop or a cycle. If we draw the precedence graph of this given schedule, means after finding the conflict pairs and then draw the precedence graph we see in previous slide, then if there is any loop, that is what saying here, if it contains any loop, precedence graph schedule contains a loop and cycle, then we can say the conflict serializable become limited. Clear? Next, in such a case we cannot predict whether a schedule would be consistent or inconsistent. Clear? So here we see in there is an example of transaction, 3 transactions over there in a schedule, that is what T1, T2 and T3. Then read of A, write of A, write of A and write of A. There is only one data item. Now loop or a cycle present in a graph. So therefore schedule is non-conflict serializable. How we can find this loop and loop in this? We can see that's read of A and write of A. This is conflicting pair. So T1 to T2, T1 to T2 we draw the direction this. This is what the conflicting pair. Then read and write. There is in other transaction, that is what T1 to T3. This is also conflicting pair. So we draw this precedence graph. Next is your, here is also we can see a conflicting pair over there. We have a write of A and write of A. Write is also conflict, and it is conflict with a T1 and it is also conflict with a T2. We can see in this graph, so we can find the conflicting pair. So we can see that loop or cycle that is present in this graph. So we can say therefore the schedule is non-conflict serializable schedule, as there is a loop and cycle is present in this given graph. We can we can find this precedence graph? We already know. So we just draw this precedence graph with the help of that conflicting pair, and then we can say schedule is non-conflict serializable because we have a loop over there. Loop may be in this all the transaction, or it may be between any two transactions also. Clear? So conflict serializable schedules is over there. We have a transaction T1, T2, T3. We just find the conflict pairs, as we know that read of A, and that is, it must be conflict in another transaction in T2 and T3. Read of A means there must be some write operations of A. So there any write operation? No any write operation. And we go for the read of B. There any write operation? No any write operation. Then go for the read of A. And there any write operations over there? No any write operation over there. So we can just move to the from this, that we can find this conflicting pair over there. So this is what the conflicting pair, and with the help of this conflicting pair, we just draw this precedence graph. How we draw precedence graph? So we have a T3 over here, T3 to T1, T3 to T1. We draw this graph. Then again T2 to T3. We draw this again. Then we have a T2 to T1, T2 to T1. We just draw this. This is what how we find the precedence graph. So we see there is a loop, but in this precedence graph there is no any loop. So we can say no loop or cycle present in the graph. So therefore schedule is non-conflict serializable schedule. Clear? So this is what all about your conflict and view serializable. Clear? So with the help of this all three condition of conflict pair, we just come to know the view serializable and conflict serializable. Okay, thank you. Next class we see the next topic. Thank you all.